Hello everyone and welcome back to Newegg TV. My name is Paul and today we have a very special video for you guys. First off, let me introduce Steve. How's it going, Steve?
Hi. It's going good.
Doing great.
Doing good.
So Steve is Gigabyte's resident overclocker, or at least one of among a few, because Gigabyte has several overclockers that they work with. And Steve, for folks who might know you more by your online handle, what do you go by when you're overclocking online?
Sin0822.
All right, so Sin0822. If you didn't recognize him before, you must recognize him now. But we're going to talk about the Gigabyte overclocking series of Z97 motherboards. We've introduced these boards to you guys already, but you might be thinking, like, who are these boards really designed for? And I think Steve's one of those folks. And actually, Steve, you have a fair amount of influence actually when it comes to the design of these motherboards, certain features that overclockers like to see. So Steve has given some input on these boards himself, as well as who are the other overclockers you guys work with Gigabyte?
I know Hikuki and then Dinos. And then there are also other freelance overclockers like a lot of Team AU and then Sophos.
All right, so shout out to all those guys. But what we're going to be doing here is a quick demonstration of LN2 overclocking. Now, for folks who are overclocking at home, this might not be so practical because this is more something set up for demonstration purposes. You can achieve world record overclocks, perhaps, by going with exotic cooling methods like these. So we're going to be showing a little bit of how that's done. And then also towards the end, we'll be doing a quick demonstration of some in-operating system overclocking that's a little bit more geared towards folks who might be overclocking at home with standard air or water cooling configurations. So first off, let's talk setup. For something like this, we have what is known as the pot, or this device, which is actually sitting directly on top of the CPU. Basically, it's like a bucket.
Yeah, like a very heavy bucket.
A very heavy bucket for the LN2, and then you got a, what's it, is it copper pretty much?
The bottom is copper, and then usually it's nickel plated on the outside.
And then apart from that, we have a little bit of footage we can show you guys here. The setup process for this, you're using Vaseline. Now, why? Why are you using Vaseline?
Well, there are many options. Some people like to use conformal coat. You just want to get into every little crevice around the CPU socket and any exposed circuitry, such as all the resistors, all the SMD components like little capacitors, even like the power stages, the MOSFETs. Those can all short out if a drop of water hits them. So you want to use something to create a physical barrier, but on a microscopic level. So you can use something like conformal coat. Some people use liquid electrical tape. A lot of people use silicone-based greases, but I like Vaseline if it's like a really quick and dirty job.
And we need to point this out, by the way. This was a quick demonstration being set up, so cutting a few corners here, but just to show you guys the demo here. And really the goal here, that the enemy you're trying to fight against is condensation, right? Because you're dealing with below room temperatures, which means condensation can develop and water and electronics don't really miss. So it's all about trying to eliminate the possibility of actual just liquid water coming into contact with certain points on the motherboard where you might develop a short.
All of this is just for that.
And then apart from that, we have a bunch of insulation around here, and that's just to keep the cold in.
Well, yeah, it's to keep the cold in, but also provide like an extra barrier. So if water was to form on the outside of the pot, then it would just drip down, but with this, it's less likely to form around. So it takes longer for the temperature, the cold, to reach the outside of this.
All right, and then we got a fan on here, which is actually kicking air out.
Yeah, kicking air out. Usually I like it a little bit above the top of the pot. So it can pull air from underneath the system and push it out. But you want active airflow to keep condensation at bay. So this one's just blowing forward, and hopefully it'll suck up the LN2 vapors. We can just give a little demonstration because the CPU temperature is getting a little high.
And the LN2 obviously will just slowly evaporate over time, but you dump it in there, and then as it runs out, you just kind of refill it. So that's a quick notes on the setup there, and I suppose at this point we can probably just jump in and start with some overclocking features. So we're just in the UEFI BIOS right here from Gigabyte. A lot of new features in this current revision with Z97.
Z97X-SOC FORCE, this model. It is Gigabyte's basically latest and greatest overclocking motherboards. It features a lot of good hardware, and the BIOS is actually almost the same as the Z87 BIOS. There are a few more options that have been added in for more extreme overclockers, which is pretty cool. And I can go through it now and go through a quick little overclock.
Let's take a look.
Right now the system is at 4.5 gigahertz, and of course at the side you can see the system speed, as well as some of the voltages. I've increased CPU VRM 2.2 volts. This is like something you do on air, like a quick and dirty air overclock to 4.5 gigahertz. So I just set the multiplier. Now if I wanted to set the base clock correctly for overclock, I can hit manual or just type in an M. Or auto, or I can just type in the base clock here and I'll do it. But here you can pick the divider, the actual base clock, and then they also have a new spread spectrum control value, which goes anywhere between 0.1% and 0.5. And you just want it put on auto because you don't want to mess with that, but that's one of the new features.
Okay.
Also, there's processor graphics clock. We're not going to mess with that today. CPU upgrade and performance upgrade. Performance upgrade will give you like both auto OC for CPU and memory, and CPU upgrade just for CPU, but I'm not going to use that either. I'm just show you how to do it normally.
We're going to go the manual method.
Yeah.
Okay.
So manual method, so I keyed in 45x on the CPU clock ratio. And XMP I just leave disabled because I just want to work on the CPU first and then maybe move to the memory and then the uncore, just one thing at a time. So we're not just CPU. Then this is the advanced CPU core features. This is quite important for what we're about to do. KOC, CPPL, filter, and selection, all these we can just leave on auto because we're not going to really use them. This is more for base clock, and automatic settings are actually pretty good. Uncore ratio, we just set on auto, and that turbo's up on the Gigabyte board. I'm just going to set this to like, I don't know, maybe 36x. A little bit lower than what it usually is. Then we can take it up later, of course. I'm going to leave all these turbo things on automatic because the board is already preset to max out all the settings. So these turbo current watts and amps, most people like to set these, but if you set them, then it actually sets a limit. But they're on auto, the BIOS guys have already maxed them out. Okay. So it's not going to limit you at all. And because these are just used to limit things. And then we're not going to set individual cores to different ratios.
I like overclocking on all cores. Anyway.
Yeah, of course. You want all cores to be at the max speed. And then, since we're doing some LN2, I'm just going to disable all the power saving features. So C1E, C3, C6/7, and speed step iced. That's all disabled. And I disabled the thermal monitor and CPU because we're going to go negative temperatures. Right now, the pot's reading at negative 8.1 degrees Celsius. While this is at 5 degrees Celsius, so it's a little bit of a big delta. Plus, the temperature probe on the CPU built into it might not go lower than certain temperatures. So you can't really trust the BIOS past 0, so you have to use something like a digital thermometer with a correct probe and something to actually go down there.
And that's why they've got all the overclocking features
wires
built onto the board, so you can actually get in there. Because you mentioned earlier, even stuff like voltage IDs are not as reliable from within the operating system.
Especially this has become very important with Haswell because of the integrated voltage regulator, the F5VR. So basically, the only voltage that the motherboard gives the CPU is the voltage input. And I can actually show you that right here. So we've set all our CPU advanced core features, and we're going to go over to voltage. And see, so we have these voltages. All these other voltages here, CPU vCore, graphics, ring voltage, system agent, I/O analog, and digital, they all come from internally from the CPU. So there's no way to go around the board like we used to and just find a read point and stick a probe there and do it. It has to be provided by the motherboard manufacturer. And so here, there are tons of voltage read points for basically every voltage you could think of on the board. And so you have to use those. And it's much more accurate than software because right here it's saying the voltage is 1.26, but in Windows it was showing 1.25 earlier, and this is 1.263. And so this is pretty dead on the BIOS, but when you go into Windows and you're dealing under load and stuff like that, the software sometimes doesn't catch up, or sometimes software reads incorrectly. CPU-Z, for instance, reads the VID, the voltage identification register from the CPU instead of actually reading the actual voltage, a vCore, for these Gigabyte boards. So having the actual read point on there is pretty important.
Now, in my experience with Haswell overclocking thus far, I usually don't want to go beyond maybe 1.25 to 1.3 volts. How much higher voltage are you actually able to run through it when you're dealing with something like liquid nitrogen?
So Intel set an upper limit of 2 volts. In the F5VR, the integrated voltage regulator, but you try to really work it up really slowly. Some CPUs will just die at 1.8 volts, even if they're really cold. I mean, cold really does reduce the resistance to a point where you can go much higher voltages than 1.3. You can easily go 1.6, 1.7, 1.8, almost safely if you're as cold as you can be, like past negative 100 degrees Celsius. But yeah, so we go pretty high.
But voltage can kill CPUs, higher voltages, especially over a long period of time. So it's really something that's only going to be seen in overclocking competitions and that sort of thing.
Yeah, of course. Or like at home, if you just want to overclock, and because they're having a lot of those HWBot competitions, and you do it all at home. I mean, you don't go to some place and just do it. I mean, sure, there are events in Taiwan and stuff like that where they bring overclockers together, but you're going to do this at home. You don't want to kill your CPU, so you're going to be a little careful with it.
And not everyone has lots of CPUs to throw around, so
no, of course not.
It's something you want to hang on to, especially if you have a really nice overclocking 4770K. I want to hang on to that as long as possible. So what's our next step here?
Okay, so I'm going to increase these voltages. So I'm going to start off, I'm going to try to go for max CPU frequency. So I'm going to drop the temperature a little bit more. Right now it says negative 23.1 degrees. I want to go around like negative 80 and just do a mild LN2 overclock just to show. So this drops down pretty quickly. Haswell does not give off a lot of heat. So the temperature is very easy to drop, and quickly too. But you don't want to go too low, or else Haswell is a cold bug, and then you just
Okay, so if you get too cold, then you actually sometimes need to warm things back up to be able to boot and everything.
And that's why I have this
that's why we got a propane torch.
Yeah. So if it gets too cold, I just hit it, and then I can warm it up in there. And liquid nitrogen is a stable gas, or nitrogen is a stable gas.
No explosions.
No explosions,
like
no.
That's
just got to watch out for the tank.
Of course.
But yeah, so right now we're at negative 34.
Okay.
And we're going to drop down a little bit more. And also, cooling down the CPU also cools down the voltage regulators a lot.
Okay.
So I've taken off the heatsink off the voltage regulator. And while it's cooling down, I could talk about some of the other features.
Sure.
So there are a bunch of buttons on this board, usually for like base clock and multiplier increases and decreases. We use the multiplier ones in Windows for this demo. And then there's also a tag feature where you save a profile. So if I want to go and save a profile under tag, I go over here and then go to Save Profiles. And then you see this last one, Profile 8, has a tag written next to it in parentheses. Okay. And I've already made one for 4.5 gigahertz in there. And so whenever you press that button in and then you reboot, the tag profile will be applied. There's also a turbo button to do like an easy, quick and dirty overclock, I think to around 4.2 gigahertz.
Okay.
OC ignition is also on this board, and that will keep this fan and the GPU, the DIMMs, all powered up. But the CPU and the PCH will be deactivated, so no data processing will take place. And you can test out stuff like your water cooling systems. You can test out voltage modifications on the GPU.
Okay.
You can, for LN2, it's great because the fan keeps running afterwards, so condensation is less likely to occur. Because if I was just to shut down the system right now at this temperature, negative 60 almost, right? Negative 57, the whole thing would get wet by the time I come back. But if I had a fan running, the chances of being as wet are much lower.
Okay.
So
it's really provides a lot of assistance when you're kind of jumping between one thing and another, and you don't want to shut the whole system down.
Exactly. So that's OC ignition. It's really cool.
Okay.
There's also a button on here. Clear Cmos is also here, but there's also a CBAT button and basically clear batteries. So if you have 4 GPUs in here, like let's say 4 R9 290X or something like that. So, and you want to clear the Cmos correctly, but the clear Cmos isn't working all the time because the battery's still in. Well, you can hit the CBAT button and that'll totally drain all the power from the motherboard, all of it. You actually have to pull out the 24 pin and put it back in to actually power the system up after that.
Okay.
But it's a really easy button to clear everything out, and you know everything's cleared out. That's a feature Gigabyte has put in recently on the last one.
Kind of like a hard reset.
Yeah. And then I can actually show this feature off right here. The trigger thing, that goes from high frequency, which is whatever multiplier you have set, down to 800 megahertz. So I just hit that, and that just went down.
Okay.
Now, what's also cool is the uncore ratio also goes down to 8x, so 800 megahertz.
Okay.
So on the fly, if you're trying to go in Windows and like one up the multiplier and then go up with trigger, you can do that. And you can actually engage trigger on 8x, hit multiplier up, and then disengage trigger, and it'll actually go up. So if I engage trigger and it goes down to 800, I can hit multiplier up. Nothing will happen, but then when I re-engage trigger, it'll go to 46x.
Okay.
So it's a kind of quick way to go up and down and not deal with stability issues while you're raising and decreasing the multiplier on the fly.
Nice feature.
Yeah. And there's a few others that are pretty cool. There's DBT, Direct to BIOS. Settings lock is basically like a clear CMOS, but like smart clear CMOS. So it'll take you back to your last good settings.
Oh, okay.
So instead of clearing your CMOS and putting in all your settings, you can just hit settings lock and it'll bring back all your last best settings.
Very nice.
And there's a memory safe button in case you're a little freaked out by the memory settings. I mean, your memory overclock. Let's say it screws up and you're thinking maybe you can't boot because of that.
Yeah.
That'll give you fail-safe memory frequency. Yeah, so and then there's dual BIOS switch and dual BIOS disable, which makes OC recovery a lot quicker, but also helps a little troubleshooting. It'll basically detach the BIOSes from each other. And there's also OC Connect here, and so I can plug in this USB drive into the motherboard right here and still access everything. So if it's like this and there's a lot of hardware going on here, I can easily put it in the USB drive.
That was a high cookie idea. If I'm not
it was. It definitely was.
Wanted some USB.
He comes up with some really good ideas. I believe OC Ignition was also his idea.
Nice.
So yeah, and a lot of these like little buttons.
And a lot of this seems like it comes down to time-saving features. Really, you don't have to completely reset every
it's all
time
about
you
convenience.
go, and that helps you kind of creep things up slowly without having to take the time to do a full restart every time.
There are also some decent hardware improvements. Some SMT DIMMs. So usually the DIMMs you see through hole, and they're like the little legs stick out, like maybe 100 of them.
Little pokey.
Yeah, and those are really vulnerable to EMI, and they can pick up noise like little antennas. So Gigabyte put SMT DIMMs, which are basically surface mounts, so then don't go through the hole, and they should give much better signal quality. And this board is actually really good at that memory overclocking.
Very nice.
They also added disable switches for the DIMMs, and also a clock generator, a secondary one, just for the base clock.
Oh, okay.
So that's pretty cool. Okay, so we're going to go into advanced power saving. So load line calibration will deal with our voltage regulator on the board. And so I'm going to set that to extreme. I'm only going to set that. I'm going to set everything else here auto. And I'm going to set PMW and phase control to extreme performance.
Okay.
You don't really have to do it. I prefer to do that. Okay, so we're going to do an OK overclock. So we're at -67.
Just keeps getting colder in here.
Yeah.
That's nice.
And so I'm going to set this to, I don't know, something safe, maybe 2.5 or actually 2.6 volts on the VN. I'm going to go to CPU V-Core, and I'm just going to ballpark it at 1.4 volts.
Sounds reasonable.
Yeah, and then I'm going to increase this ring voltage to 1.2 volts. Now, ring voltage doesn't really help so much with the CPU overclock as it does like stabilizing the CPU clock.
Okay.
So I'm going to hopefully get it a little stable. That's all we got to do for the CPU right now. If you want to do base clock overclocking, you mess with the PCH voltages, and they work pretty well. And DRAM, you mess with the DRAM voltages. And you can change these in Windows through EasyTune and GTO, and I'm going to demo that in a little bit too.
Nice.
Miscellaneous. Now I'm just going for top speeds, not benchmarking. So I'm going to take DMI generation from 2 to 1. So that should maybe help if there's any signaling issues. That's really helpful for base clock overclocking. And then PC health status, we can see fans and everything like that. I think we're good here. So we can go into Windows.
All right.
So we're -80 degrees Celsius.
That's pretty chilly.
Yep.
It's nice because it's actually a very, very warm day outside right now in Southern California. So
Yeah, it's pretty hot out there.
yeah, usually we have to crank up the AC, but LN2, it's a great way of doing it as well. One of those little bonuses you get from overclocking, I suppose. All right, so just booting up into Windows for right now, and let's see. This is Windows 7 Ultimate, by the way. In case anyone was wondering.
But we didn't install the graphics driver, so.
That's true. So we have large icons on screen.
I'm going to change the resolution.
All right.
Okay, so we're going to do something quick and dirty. I'm just going to see how high I can get on 1.4 volts on the CPU.
Okay.
Well, actually, I can change the voltage a little bit too. Now, for this kind of overclocking, I prefer to use GTL. However, I'm going to perhaps use EasyTune for this one.
Okay.
Changing the voltage right now. And I'm going to use the buttons to change the multiplier.
And GTL, for folks out there who aren't familiar with it.
Oh, GTL is Gigabyte Tweak Launcher.
Okay, and that's you were talking about this earlier. It's sort of a really bare bones overclocking.
It's really bare bones. I mean,
so
you can take a look at it here. I can key in all the voltages I want.
And this is something that was really designed specifically for overclockers like Steve here. The EasyTune utility that Gigabyte has developed as well is a lot more geared for home users, so there's a lot more automatic functions and that sort of thing.
So actually, we're just going to use GTL right now.
Okay.
So right now, I'm going to take that V-Core up because I just didn't want to boot with it because it would put load on the V-Core.
Okay.
So I'm going to set this, and this is available for download for anyone. I believe it works on almost all the boards.
Okay.
So it's not only for the SoC Force. So I'm going to go 1.6 volts on the CPU core. Now you want a delta between these two. I'm going to have 1 volt delta between 2.6 and 1.6.
Okay.
I'm going to increase this easily to like 55x, 5.5 gigahertz.
All right.
And we're at -73. I'm going to go to -80. I'm almost at LN2 here.
Oop. It's all right. We should have just enough.
Yep, just enough. Just enough for this. So 55x, hit apply, and it did it. 5.498 gigahertz.
Nice.
And if I want to do base clock, I can do that too. So I can go, well, I'm just going to do this. Now, I'm going to do the rest with the multiplier, and I feel okay with that. So I'm going to increase the VN to 2.7 volts.
Okay.
And I'm going to increase this to 1.75 volts. And you see right here, it's going 1.600 volts, but my multimeter is showing 1.633.
All right.
So there is a discrepancy, and it's actually higher in reality, which is a little scary.
Yeah.
But since we set 1.6 volts, the vid is 1.6, and that's why that's showing 1.6.
Okay, so it's reading the vid rather than the actual
So I'm going to apply 2.7 and 1.75, and now 1.75. And now I'm going to go to 60x, because it should be able to do this.
Okay.
And then we'll use OC Touch. So now we're at 60x right here, there we go.
Ah.
See, that crashed. Need more voltage.
Right,
colder
so,
temperature. But that's how it works. You just keep messing with it in Windows or you use the buttons.
And I did want to point out here, this is actually a pretty new CPU that you're working with right now.
Yeah, first time I actually tried out the CPU,
okay,
so I have no idea where it goes.
A lot of times, of course, especially with Haswell, there's a big variance in how much a CPU can actually overclock.
Of course.
And there's a lot of little tweaks and tuning you can do in there, like a lot of the settings that Steve was just mentioning. So this is not a cherry-picked CPU. This is just one that we started out of the gate with.
So I can just go show like a nice in Windows overclock.
Sure.
Okay. So we're going to take these voltages back down, but you see, once I reboot, it's back to the voltages it was at before.
Right.
So CPU VN is still 2.6 volts, just like it was set. vCore is still 1.4 volts. So once it restarts, everything is still intact, and we go in the BIOS easily, and we can change stuff up, or we can go back in Windows and try again.
Okay.
So that's the beauty of like in Windows overclocking.
And that's also the give and take of overclocking in general.
Yeah,
You kind of push it as far as you can. Blue screen, okay.
Yep.
Restart, try some new settings, and see how far you can push it. Which is why all of those time-saving functions built onto the motherboard are so helpful, because you don't have to wait, 1 or 2 or 3 minutes in between trying out different settings.
Exactly. So I'm just gonna exit out here and go back into Windows.
Okay.
Try it one more time.
Okay, so we're back into Windows now, and we have EasyTune loaded up.
Yep, we have EasyTune loaded up, and we're gonna show a little bit of EasyTune's capabilities. And right now we're at 5 gigahertz.
Okay.
At 1.397 volts. Well, actually 1.426 volts.
Okay.
So that's the beauty of a digital multimeter. We're at negative 70 degrees Celsius. And so we're going to pour the rest of our LN2 in here.
All right.
And then increase the CPU multiplier.
Okay.
So now we're about negative 70 degrees Celsius. Should hold it for a little bit. So I can change the host clock, which I'm not going to do right now, or I can change the cores. So right now we're at 50. So I'm going to pull it up, and it's going to pull all cores to 51.
Okay.
I'm going to hit apply. And now this will go to 51, so now it's 5.1 gigahertz. Yep, 5.098. So we can also change vCore and stuff like that. So right now we're 1.39. I'm going to go to 1. How about 1.
That's a lot of decimal places there.
Yeah, 1. It's very precise.
Very, very accurate.
1.7 volts on the CPU core.
All right.
And we see CPU Z reflects 1.692, and we have 1.72 here on digital multimeter. Temperature is negative 75 degrees Celsius at 5.1 gigahertz. So we're just going to slowly increase this to 53x. Okay, and that worked. And we can also use the buttons. So I'm going to press the button here, and you'll see it go up 1.
Okay.
Oh, that's the wrong button. There we go, up 1. That's 54x. Now you'll see it on CPU Z, and you'll see it here. This is the hardware monitor, also a new part of EasyTune.
Okay.
We can also do advanced DDR OC in EasyTune here, but you can't really change the memory settings on the fly anymore because Intel locked that down.
Yeah. And
you can't change the memory frequency on the fly either, but this is more of like a monitoring thing to see what your timings are.
So memory overclocking might take a little bit longer.
Yep, yep, exactly. So that's basically how to use EasyTune. I can change the voltages on the fly, CPU vCore, system agent, CPU VRN. We're 2.6, that's okay. I'm at 1.7. The delta is large enough. So I'm actually going to exit out of EasyTune real quick, or actually I'll show a little bit more EasyTune. So we'll go up a little bit more, 55x. We're 54 right now, and then I'm going to apply that. 55x easily. And we can use the multiplier one more time. So now 56x. Okay, so now I'm going to demo the trigger switch. So we have the CPU frequency here at 5601. So if I hit the trigger, now it should go to 800 megahertz. There we go, 801.
Nice.
So 801. So now I can actually increase the multiplier button by 1, and then when I come back, it should be at 57x. Yep, 57x, cool, right?
Very
so I can go back down, I can increase it by 1, and now when I go back, it should be 58x. So when I go back, I can go 58x. Yep, and then I can press F7, and then this CPU Z will save a little thing of it. So that's pretty cool, right?
Nice.
So that's about all I got to show right now. I mean,
excellent. And
go back in the BIOS.
I know there's so much to talk about when it comes to overclocking and all the little functions and features, but I think that was a really nice quick demonstration, not only of the using LN2, setting that up, but also the features of the Gigabyte Z87 overclocking boards. And if you're looking for these online, we'll post links in this video's description, but the orange ones are pretty much those are the overclocking colors for Gigabyte. They also match nicely with other orange colored components in your case, just an extra added bonus.
And these have a lot more orange on them than before.
They do. They do. They look quite nice, actually. I really like the color on the heat sinks and all that kind of stuff. Aesthetics, though. But I think that wraps it up for this video. Steve, thank you so much for coming by today.
Thank you for having me.
And we look forward to seeing you again for some more overclocking demonstrations just like this one. Guys, hit the thumbs up button if you enjoy LN2 overclocking and extreme high frequency stuff like we've been showing you today. Don't forget to hit don't forget to leave us a comment too down in the comment section below. Let us know what you think of this board and overclocking of this caliber, and we'll see you all next time.